So first, yeah, one more BFS problem, and this problem, I'm gonna link it, was part of I posted in weekly contest link, just extra problem, but it's another BFS problem, but one level above just the basic version. So just definitely worth knowing how to do this and like splitting the steps up. So I definitely encourage thinking about it a little bit, and then we'll talk about it. So maybe has anyone tried this problem? If not, we'll take like 5 minutes. Kind of think about this problem. So you don't need to write any code. How is this problem different from a regular BFS problem? And in what way would it be different? Yes. Does anyone want to, like, how would you process this problem? What do you think?
Is it because of the walls?
So walls are a part of a lot of BFS problems. If you hit a wall, then it's just somewhere you can't go. So you wouldn't move forward in that direction. You wouldn't queue that direction up, something like that. So first of all, it might be good to visualize like what's actually going on and what you need to figure out. So you need to get to one of the boundary spaces, and maybe some of these other boundary spaces, these might be blocked off. And then for this example, well, the answer is going to be to go right, right, and then down, down, right. And that's also the shortest path for A to this exit, but there's also another exit. Seems like you might need to do some kind of shortest path search from A to some of the other squares. But you can't overlap with a monster, right? And then, so what does that actually mean? So at time 0, you can't enter the monster square, right? A can't move to monster square. So you can also assume this is kind of like a wall, right? And at time 0, you can go here, you can go here, you can move in that direction. The monster won't be there yet. But at time 1, after moving one space, and the monsters move, they're potentially in any of these regions, right? And then potentially they're here. There could be a monster here. And then the monster, the minimum time for a monster to get somewhere is also going to be shortest path, but there's multiple monsters. It's kind of part of the question. So anyone want to talk about like what they think? Multiple BFS. Yeah. How do you go about solving this? Like, how many times do you do BFS, and what do you do?
I can run BFS for each monster and also player and compare if they're like compare
if you wanna
if they're like
if you wanna go directly, if you want to draw on here. So like
So, oh, neat. Well, kind of fun. So I run the BFS for Monster here, and I run another BFS for. Kind of change the color, yeah, like this, and if you see here, the number here is like Monster's pass number is lower, like higher than the player, so player can arrive here faster than Monsters. So
Yeah.
yeah, using that kind of logic, I can like kind of search along this path, but I got this like idea, but I'm still not sure how to use this. Like
Okay.
I have to somehow search for paths that escapes.
Yeah.
Yeah, but maybe maybe I can use like back reference. Like if you do BFS, you can also add back reference, you know.
Back
Then
reference. Okay.
yeah, then we can use from escape like back and check if like there's any monster path that is that is cutting off the path, kind of like that.
So you'd have to search from each exit,
Yeah, and
but that would
then
take a long time, right? That would
yeah,
you'd have to
and I'm not sure
get
like
through it.
I'm not even sure like running multiple BFS like is like viable here, like in terms of like time complexity. It's all ON 2 squared, right? Like ON squared, right? One BFS is, then it's going to be
Yeah, all
ON
the V
2.
plus E, and then so N and M are a
Yeah, and
thousand. So there's
yeah,
like a thousand.
that's kind of close to the limit. Like it's kind 1 million is kind of limit, right?
10 to the 8 around
Yeah, 10 to the 8 around. Like I believe it's over
is
that.
yeah. So a grid, you might think of it as every index is like a vertex, right? A vertex is equal to m by n or m by n. And then the number of edges is going to be less than 4 times. There's you can think of it as a undirected graph, and there's a maximum of 4. So edges is less than 4 times vertices, something like that, right?
Yeah,
And then maximum, so this is like 10 to the 6, and then this is like less than 4 times 10 to the 6.
any at the worst case, you like traverse every cell, so right. So that'll be like n squared, I think.
Yeah, but you can't do BFS. BFS is going to take maybe 5 times 10 to the 6 operations at most. And you
Yeah.
can't do that 10 to the 6 times, right?
So it's kind of more than like 10 to the 6. And I
You
have to
could do
do it for like
BFS.
if I do it for like every monster, like
Yeah,
it's like 10 to the 9 or something.
yeah.
Uh,
Or 10 to the 6 vertices, and then each BFS would take 10 to the 6, so maybe like 10 to the 12. Somewhere around.
okay.
And worst case scenario, you can have so you can have a bunch of monsters. You're just surrounded by a bunch of monsters, you know. This is valid. I guess it's A.
Yeah, right.
Yeah, this
Then
is
it's
possible
going to
as
be
well.
like crazy.
Yeah.
Yeah, Yeah, crazy number of computations.
Yeah, so you can't do BFS from every monster.
Yeah,
can't do
then, but we have to somehow decide like whether monster can cut off the path though. Like,
Yeah. So the first thing might be to think about, what if there is one monster? How do you solve the problem? So let's say this monster doesn't exist. This doesn't exist. This doesn't exist or something. Maybe here, 0, 1, 1, 1, 2, 3, 4, 2, 3, something like that. If there was only one monster, how do you approach this problem?
but the thing is like, for each turn, no, but oh yeah, never mind, never mind. Let me think about this.
Could you not just use BFS if there was only one monster, or would it still go over?
Yeah, you can do, yeah, this is a BFS problem. But so
So
let's say
maybe-
you run BFS on the one monster, you get the values, and then how do you solve this? So one way of thinking about it, kind of as a hint, would be, well, A, if the current time might be 0, and then you can go to any square that's less than the current time, right? So if you pre-compute the time it takes for the monster to get to any square, then you can check while you're doing BFS. Yeah, current time of A should be less than current time for M. So yeah, keep track, just do BFS, but keep track of the current time. And then if that square is less than the current time, then that means the monster can already get there at that time. So you kind of think of it as a wall. You don't go in that
So
direction.
it's kind of like setting the war, you mean? Like
Yeah,
setting the
kind of.
war starting from the monster at every time.
Yeah,
By
but
implementing time.
but you don't want to do it both at the same time. You don't want to do both of these BFS at the same time. You can do it separately. And while you're doing BFS for A, you can just do a check for the current time versus the weight of each index. I don't know if that makes sense.
But isn't that like same as like running multiple BFS though?
Yeah, so you have to run at least 2 BFS. Like
So
split it
only
into
2
two.
BFS.
Yeah, you can't do A and M BFS at the same time. And then if you do BFS M times, then let's say this is 0, then the monster distance for each one is going to be the minimum between this monster distance and this monster distance. So you can do multiple BFS for here, but another thing you can do is actually just do BFS and push all the monster indexes into one BFS, and then start with 3 of these indexes that you start with. If you think about BFS,
Yeah, it can be
Yeah.
like considered as one BFS. Like I'm
Yeah.
seeing your idea. Oh yeah, that's neat.
So yeah. So the point is you can actually start with multiple indexes and then just run one BFS. You can push in multiple of the monster BFS distance. And the reason why, maybe one intuitive way to think about it is, let's say you start with 1, and then you can go to here and you push these indexes, right? But if you think about it another way, you can think of at some point after you finish this, these are in the queue, right? And you have multiple spots. So this is completely valid, right? So maybe I didn't explain that super well, I think, but you can have multiple zeros. You can add multiple of them. So you can add multiple locations and it'll work. And if you go to the same spot multiple times, then only add it to the queue if you're updating the number. So make sure you have an extra check in there somehow. And then you also have to write out the path, which is also kind of annoying. So this is definitely worth doing, but definitely give it a try. Yeah, implementation. Yeah, definitely have to. If you can solve this, I think you're pretty much mastered BFS. So
I'm sorry, I came a little late. I was wondering if we were going to go over like some Division 2 problems.
yeah, okay. Division 2. I would say a lot of it is going to be so around half of the problems are the exact same as Division 1, and then the rest of the half are going to be replaced by like complete search style problems, and then maybe some stuff you can solve with DFS. So I would actually really encourage practicing DFS with BFS and generating patterns of like exponential patterns like 2 to the n or 3 to the n, generating these and doing n factorial. So there's a little bit talking about that in a presentation. So maybe look at that and definitely practice those types of problems. And also in general, complete search style problems. So you can, if you ask later, can I think we'll try to compile some really good complete search style problems that'll be helpful, I think. So for the most part, it's like, what do you iterate over? And sometimes certain numbers you can't iterate over. And it's just like identifying the time complexity and stuff. So if you can get there, it should be good for Division 2. And there's going to be a certain number of problems like you just can't solve.
Yeah, it was because the first few problems is like pretty solvable, and then later on,
Yeah,
it pretty much becomes unsolvable.
yeah, a lot of it is pretty tough. So I think I aim
Because
for
my
yeah,
biggest problem is like I don't know like the algorithms. You know what I mean? Like
Yeah.
DFS and BFS.
I'd say do DFS because there's a lot of DFS, the 2 to the n, 3 to the n, and n factorial problems you can solve with DFS. So that's really, really important, I think. So I'd say definitely practice DFS. But I will try to compile some good problems, kind of like the DA hack contest from last October. So yeah, something kind of closer to that, and trying to solve those problems more quickly should be really helpful. So I definitely encourage trying to implement this, and if you can solve this problem, I think you've mastered BFS for sure. I think I'll pause. So for a monster, for every index, if it's a monster, I added the pair to pair intent vector monsters, save the pair, and then a monster distance of that index I just set to 0, and otherwise the monster distance is set to infinity. It's the same thing as doing BFS for each monster, but you don't want to run the BFS if you have ways of like making sure you don't go too far. It's good, but yeah, I just wrote the second BFS and this n squared for the monster. if you run multiple BFS that has overlap, okay, so let's say you run BFS, right? You run BFS from here, 0, 1, 2, 3, 4, 5. You run BFS from here, 0, this is less. So you overwrite 1 and then 2, and then I guess like when you hit here, you could stop, but you could do something like that. You could implement it, but you are overlapping, stuff like that. It's I definitely would just push all the monster indices into the queue. So auto pair queue, and then I just had a pair of in which is not good practice probably, maybe, but as long as you understand. And I just want to keep track of the current distance and the thing. But yeah, current distance and the indices. You just stop and squared. Yeah, you could visit every index just twice at a maximum. So the first you do, you have to go through every single possible adjacent place, and then for every next one, you stop when there's an overlap, right? So I guess you can keep on doing it, but there is a significant overlap, right? You're eliminating some numbers. I'm not sure, but can't get current time without running another. What? You should we solve you can think of monster equals 1 queue push into BFS. Yeah, if you add all the monsters into the queue, then it's the same thing as doing multiple BFS, but you just stop early, or you definitely can't do a full BFS for each monster and then get the minimum for each index as the monster distance. You can't do that, but current time, worst iterate and squared. But you might need to revisit, right? Because let's say for like this one, this is 4 right now. If you start with this, then it might be 4 right now. And then, so when you start BFS from here, you have to eliminate that, and stuff like that. So there are values that you're eliminating. And you can stop when you hit that overlap, but you'd have to code that in, or else you can't do like BFS and then the distance is the current monster distance and the new monster distance at this index. It's the minimum between those. That does work. You can set it as the minimum, but it just takes too long with the max case. So just add it to the queue, and then I personally had it as I just had a vector of pairs, and then I added it to queue, and then I also had a pair plus the distance started 0, and then for every direction, check if it's out of bounds, check if it's a wall, check if it's visited already. I don't know if you need the visited. You don't technically need the visited, but, and then if the monster distance is strictly less, then you want to wait, monster view. Then yeah, so the current time plus 1 you update the distance with the current time plus 1, and then you add to the queue the point plus the new distance or something like that. And then the second one, it's kind of like doing another wall check. If the distance of I of j plus 1 is greater than or equal to the monster distance of I of j, and continue. So the check I had for the monster. And then if you want to print out the direction, you also need the previous for each index. The first time you get to the index is going to be the direction. So the previous is always, you can select the previous for a single, let's say you start at A, right? And then the previous is going to be that, and the previous is going to be that for this and here. And this is always going to be, R will always work, and L will always work for this box. So in the code here, I just had I just selected the char and read the char for the previous one, and then start with the end place. When you hit the end with the A, where is it? When you hit the end, then you can kind of select that as the current node. And then, so this is always R, because in a greedy way, you're always going in this direction, and that's the shortest path. So this character doesn't change. So I just gave it a character, assigned a character to that index. And so this will always be down, this will all be left, because you're coming from the right side with the shortest path from A. So you're always going to have these, and this can be either up or to the left, but it's always going to be the same one. It doesn't matter whichever one, but you don't have to update it. You just do one of the shortest paths. So I just saved the character for each index, and then I have the previous index for every visited index, and then start at the end, and then so add like, so this is R, you came from this square in the shortest path, and then I add this char, add this char, add this char, and go to the previous index. So every for every index that I visited, there's the previous index. So there's that in there as well. And then you just reverse the string, and it becomes right, right, down, down, right. Whereas you work backwards and then reverse that string. So that's how you write it out. But it's for the writing the path out, it might be good to start with a different problem. So these two problems, labyrinth and message route, these require printing out the path, and these are more basic problems. So maybe give these a try first. Like combining a bunch of elements together is always going to be pretty tough. So the most important thing is being able to get that the output. And if you do CSES, if you do this website, let me check. Monsters. The monsters, you can check results, and I had like time limit exceeded and stuff because I did the monster part wrong. But you can check like if you're getting, oh yeah, it just errored out, but you can check that you're getting yes, no, and you're getting the right distance. So even if you get the wrong one, you can check. So you can submit without getting the right answer, and it'll tell you like what's your correct output and then what's your output. So if you get yes and 7, you can think of it as good, and then add that feature of going printing the path. So you can do that as well, and that's probably helpful. So go to the results page. So the first time I did it, I just did the monster BFS like m times for every monster, but then did the other way in pass. So some sites don't show it, yeah, like Caddis and stuff like that. So the CSES page, that makes it a little bit easier, yeah, for sure. But it's also pretty helpful. These are, yeah, relatively standard problems on that page. So, hopefully that's okay for the, so set the pair, start with the ending coordinate, have the end somewhere, figure out the end, and then the previous index becomes the current index until you get to the start. So just to keep on doing it, and then add the character for each index. Well, that's the general thing for the printing part. So really kind of long. So you do BFS once for all the monsters, BFS for the dude, and you have to save the previous indexes and indices, and it's convenient to save the previous character, like the direction that you traveled. It's definitely super convenient to do so, but it's not technically necessary as long as you know the previous index. You don't necessarily need the previous character, but I definitely recommend saving the previous character as well. And then save the final index. So a pretty long problem overall. There's probably a better way to write this, but you do have to write BFS twice just because you do different things with the monsters and with the dude. So minimum, you have to write BFS twice, plus you have to do some searches. So I don't think you can get it much shorter, maybe 100 lines, but yeah, pretty long overall compared to a lot of these other problems. Copy paste. Yeah. Yeah, the general thing doesn't change too much. I definitely try to get used to writing this thing, and then yeah. So for here, instead of, I usually do like for every pair in directions, and I usually do that, but for here I did a for loop with d equals 0, d is less than 4, and then I had a where is it? I had a directions vector that says up, down, left, right, and I just saved the previous character, and it corresponds with the this. So I just saved the previous character by doing that. Then yeah, save the directions and stuff. Concerned about vector stuff. Which part? I have was dynamic of.
So in the directions, vector directions.
Oh, vector directions.
Yeah, there I think
Okay.
it can possibly dynamically allocate and
What do you mean about that?
So I think
Here.
yeah. Because vector is like based on the heap, you know.
Vector. So what's? I mean, wait. This is like. This is the same thing.
I mean, I know the
as
syntax, but like,
statically.
I'm not sure. I think it can, maybe compiler would do the job better there.
This is the same thing as doing like
Yeah.
for int d equals 0, d is less than 4.
Yeah, I mean, vector itself
Or
is like supposed to be on heap, like it's using the heap
Or-
memory.
Heap
I mean, STD
memory.
vector.
Oh, heap memory. I'm not quite sure, but
Yeah.
this is a vector of 4 elements. It shouldn't be an issue at all. Like I don't.
Yeah,
I'm not,
I think compiler might optimize it, but yeah, maybe we can profile later.
yeah. There's
Like,
no way. Yeah, this is just like
yeah,
this
yeah,
could
but,
be
because like I was hit by that something like that before. Like I used like vector blindly, and it turned out to be like really slow.
like you could do this, right? Like
Oh
this
yeah,
is
yeah, right.
yeah. This is, it's just
Yeah, then
an
it
array.
will be definitely like step allocated.
Yeah. This is statically allocated. Like
I mean, it can. I mean, Aaron, it can like cause like order of magnitude. Like it can be like 10 times slower. Like then
if you initialize vector initialize in this form, it shouldn't be that slow. It should be the same pretty much as the thing. And I just want to use like iterators and stuff. So it's yeah, it's
yeah.
just yeah. The standard, you should use standard containers for the most part, I think.
And it just that cost that wrong me kind of. But I think it can be fine. Like
Yeah.
it passed the test, yeah. Right.
Yeah. Yeah, I don't think I should worry about that. Yeah, this is like statically allocating pretty much. You're not really, and for the most part, it's like a container is like a pointer anyway. It's
I'm
not
kind of
like,
sure vector is heap allocated though. Like, but compiler can optimize it. Like it's whether or not like compiler will optimize this thing. But yeah, so it might be better to just use C style array. Like you can use like the what is that? The range for that. Like you can still do something like this, right?
yeah, I can still do range
Yeah, even if it's on like C star array.
Yeah, I think so.
Yeah, then I think it would be better to just do that because like it can like possibly cause something like very slow.
I'm not completely sure. Yeah, maybe I'll try to look it up later. Yeah.
Yeah, we can profile later, but
Yeah.
like it's one of the possibility. And yeah,
But yeah, BFS. Yeah,
it's
some of these
not something
things
like that
just,
important though. Like we have to first solve the problem first, right?
yeah.
So
And this is like honestly hard to read and hard to write. So just using
yeah.
C style is definitely good as well. I actually I wrote a snippet for like vector int.
Oh damn. that's
So,
yeah, that's neat. I gotta do that as well.
vector long.
Uh,
Yeah. I have a problem with like doing like was it using LL as long or like define LL equal long or something like these type of things I'm pretty like personally not a fan of, but using
yeah, that's kind of
snippets and
cursed.
stuff. Yeah, type def, yeah. Yeah. Define type, yeah,
I've
type
seen some
definition.
people like
Yeah,
doing it a lot. Like
yeah.
it makes code like really unreadable.
Yeah, or I mean everything you just get used to it, I guess. But yeah, stuff like this, I honestly think it's probably bad. It's hard to read, and it's really easy to make mistakes. There's so many. So honestly, this should be written differently probably, but for the most part, if it works, it works. Is the general thing. Or
Yeah, right.
yeah. So that took like an hour overall, but These are slightly easier problems, also from the bonus section from last week. Definitely, definitely try to. These are pretty simple, but being able to do it, yeah, you definitely need to be able to do it, I guess. So just, and I would do it using DFS specifically. Like try to do it without other tricks. Just do it with DFS to get used to using DFS. So I guess Amir is not here anymore, but yeah, this be really good practice for creating DFS. So maybe, okay. Yeah, DFS pretty tough, but once you get used to it, it's just the same pattern overall. So, and if you guys have to leave, you can go. It's 5:30, but maybe let's do that Vetsy if you want to work on this for a little bit and just go over by a little bit, if that's okay. If not, see you next week. I'm gonna pause. This just lastly, for this Vetsy problem, you can use next permutation if you're using C++, and it's just a few lines. It's very, very quick. But if you use DFS, it's a little bit harder. So, okay. Bye.